Over the last few lessons, we've seen how the IP-PBX performs two key roles in the enterprise network. It manages call routing through dial plans, routing rules and location, and it applies features. Now, over time, the features offered have evolved and grown beyond measure, some now with over 500 different features. Amazing! But, amazing as it is, some would argue that hundreds of self-contained features is not necessarily a good thing. The more features it has, the more it costs. And what if I only want some of those features? Do I pay for features I don't want? And what if, after buying a PBX from one vendor, another vendor invents a great new feature that I really need, one that mine doesn't offer? Do I throw mine out and buy the new PBX just for its new feature? And what if I need a custom feature, something specific to my enterprise, to my specific business needs? How do I get custom features? Now, these are all good points. The thing is, having made a purchase, the investment obliges long-term commitment to that PBX vendor and a dependency on that vendor for all new features. There's a danger of vendor lock-in. An alternative is to completely separate out routing and features from the PBX into two separate components in two logical layers: features at the application layer and routing at the session management layer. Now, in this lesson, we'll discuss session management and separate feature servers. By the time we're done, you should understand the notion of session management and separate feature servers and how together they offer greater control and flexibility. We'll also touch on the ISC interface, a standard IMS mechanism for invoking features on remote application servers. Okay, separating PBX functionality into two layers. The lower layer is the session management layer, comprising just a session management server. The upper layer is the application layer, comprising separate dedicated feature servers, each offering a feature or range of features, perhaps one with call logging, call barring and call blocking, another with call forwarding and another with call recording. There could be conferencing, voicemail, presence, and so on. In fact, having separated features away from the PBX, we've removed the dependency on the PBX vendor to also supply features. As new features evolve, they can slot in alongside the others. With separate feature servers, we can choose the features we want, adding in and paying for only the features we need. The session management server is an advanced SIP server designed especially for managing routing to feature servers as well as to other endpoint phones. It's typically a SIP registrar and location server, receiving registrations from enterprise users and routing calls between them. It also knows about the various gateways and border controllers in the network, as well as any legacy IP-PBXs, and applies dial plan routing rules to route calls over the best routes. Now, features are applied on a user-by-user basis, the server keeping a profile for each user, each configured with individual routing rules. Imagine Dave wants to call Nath. Receiving Dave's invite, the session manager, acting in originating mode, checks the caller has a user profile, pulls it out, gets details of the first originating feature, and routes the request to the feature server that serves that feature. Having the request, the feature server then applies the feature, in this case logging the call in the system before passing the request back to the session manager, where details of Dave's next feature are retrieved, the call barring feature. Again, the request is routed to the feature server that serves call barring, the destination address is checked, and if not an international call, is passed back to session manager. Having no more originating features, it switches to terminating mode to consider the callee. Receiving the request, the call forwarding server applies the feature, checking if call forwarding is enabled. As it happens, just moments before, Nathan enabled call forwarding to his mobile before leaving the office. With call forwarding enabled, the feature server changes the dialed request URI to Nathan's mobile number, and passes back the request. That done, feature routing is complete, and the session manager turns its attention to call routing, checking its dial plans and, in this case, routing the invite through a PSTN gateway to Nath's mobile phone. Rather than apply features itself, as does the PBX, the session manager simply routes calls to separate servers that themselves apply the features. In this way, when a great new feature arrives, we add them in and simply update the user's user profile with details of the new feature. Now, as well as routing to the call forwarding server, the session manager will also route to the great new feature server. There's no reliance on the PBX vendor for new services. We have complete flexibility on which features to apply and when to apply them. It also offers us more flexibility on upgrading features. If a better call recording service comes along, we simply swap them over and enjoy the better feature. There's no vendor lock-in. Likewise, if we need a custom feature, it's much easier to build an application, perhaps on an application server, we'll talk about them later, and slot it in as a feature server, than it is to build custom features into a PBX. So how does the session manager actually route a request between itself and one or more feature servers? Do you remember back in Chapter 5 how an entity forces a request over a given route, diverting it from its anticipated path? Do you remember the golden rule? That's right, through the route header. If one or more route headers exist, the request is sent to the address in the topmost route header. Session managers route requests to feature servers by adding route headers. So, on finding Dave's originating call needs the call logging service, the session manager server adds not one, but two route addresses, the call logging server and itself. Receiving the request, the call logger server applies the feature, then takes the invite and strips off its own route address, and routes the request to the next topmost route header, back to the session manager. The cycle continues till all the features have been applied. Nice. One more thing real quick. Where a feature server offers multiple features, like this one, on receiving a request, how does it know which of those features to apply? Well, session management borrows a trick from the IMS, the IP Multimedia Subsystem. We'll introduce the IMS properly later, but for now we'll just discuss its ISC interface, the IMS Service Control Interface, used by session management components to tell feature servers which feature to apply. You'll remember that route addresses can take one of two forms, just SIP and the hostname or IP address, or SIP plus a username and the hostname or IP address. Now, the ISC interface simply uses an application identifier in the username part of the route header. So, to apply call logging, the session manager includes the call logging feature's identity in the username part of the route header. Then, receiving the invite and seeing an application identifier in the username, the feature server knows to apply the call logger feature to the call. So, in summary, PBX functions can be separated to routing by a session management server at the session management layer and feature application to a range of feature servers at the application layer. Separating these functions offers greater control and flexibility and also prevents vendor lock-in, the dependency on a single vendor for call features. Session managers route to feature servers over the ISC interface, including an application identifier in the username part of the route address.